The National Electrical Code, or NEC, recognizes several grounding mediums. These include metal water pipes, metal underground gas pipes, ground rods, ground plates, and concrete encased electrodes. Bonding and grounding serve distinct purposes in electrical systems. Bonding connects two or more conductive objects together to establish a common electrical potential. Grounding connects an electrical system to earth to provide a path for fault currents. For water lines, the NEC typically requires a number 4 or larger copper wire to be connected to the cold water pipe, acting as a grounding medium. This requirement applies unless the water line is made of non-metallic material. Ground rods have specific requirements. The NEC mandates a minimum of 2 ground rods, each at least 8 feet long, driven into the ground at least 6 feet apart. A number 6 or larger copper wire is used to connect the ground rods to the grounding electrode conductor. When a metal water line is replaced with a non-metallic material, the ground rods become the primary grounding medium. In this scenario, the number 6 wire to the ground rods is generally acceptable. This is because it typically meets the minimum NEC requirements for grounding conductors, even when a non-metallic water line is present. The water line is considered a grounding medium when it is metallic and effectively grounded. Ground rods are always a grounding medium and become the primary grounding medium if the water line is non-metallic. The number 6 wire to the ground rods is often acceptable because it meets the minimum NEC requirements for grounding conductors, regardless of the water line's material. Now, let's delve deeper into the specific requirements and considerations for each grounding medium, starting with metal water pipes. When a metal water pipe is used as a grounding electrode, it's crucial to ensure that it's in direct contact with the earth for at least 10 feet. This ensures a reliable and low impedance path to ground. The connection to the water pipe must be made within the first 5 feet from where the water pipe enters the building. This minimizes the potential for any sections of non-conductive pipe to interrupt the grounding path. As previously mentioned, the NEC typically requires a number 4 or larger copper wire for the connection to the water pipe. However, the exact size of the grounding electrode conductor depends on the size of the service entrance conductors or the equivalent for a service entrance cable. Refer to NEC Table 250.66 to determine the appropriate size based on your specific installation. If the metal water pipe is supplemented by an additional grounding electrode, such as a ground rod or ground plate, the size of the grounding electrode conductor to the water pipe can sometimes be reduced, as permitted by NEC Section 250.53. It's important to note that interior metal water piping systems must be bonded to the service equipment enclosure, the grounding conductor at the service, the grounding electrode conductor, or the grounding electrodes. This bonding ensures that all metal water piping within the building is at the same electrical potential, minimizing the risk of electric shock. Moving on to metal underground gas pipes. The NEC generally prohibits using metal underground gas pipes as the sole grounding electrode. This is due to the potential for gas leaks and explosions if the pipe becomes energized. However, a metal underground gas pipe can be used as a supplemental grounding electrode if it's electrically continuous and has a resistance to ground of 3 ohms or less. The connection to the gas pipe must be made on the customer side of the gas meter. Now let's look into ground rods. Ground rods are a common and effective grounding electrode, especially when used in conjunction with other grounding electrodes. As stated before, the NEC requires a minimum of 2 ground rods to be installed. This ensures redundancy and improves the overall effectiveness of the grounding system. The ground rods must be at least 8 feet long and driven into the ground at least 6 feet apart. This spacing minimizes the interaction between the rods and ensures that each rod is effectively dissipating fault current into the earth. Copper or copper-clad steel ground rods are commonly used, with a minimum diameter of 5/8 inch. Other materials and sizes are permitted, as long as they meet the requirements of NEC Section 250.52. The grounding electrode conductor connecting the ground rods to the service equipment must be sized according to NEC Table 250.66, based on the size of the service entrance conductors. A number 6 copper wire is often sufficient for typical residential applications, but larger sizes may be required for larger services. The grounding electrode conductor must be securely connected to the ground rod using listed connectors or clamps. These connectors must be suitable for direct burial and resistant to corrosion. Ground plates are another type of grounding electrode recognized by the NEC. A ground plate is a metal plate buried in the earth to provide a connection to ground. Ground plates must have a surface area of at least 2 square feet exposed to the surrounding earth. They must be installed below the permanent moisture level or at least 30 inches below the surface of the earth. Copper or galvanized steel plates are commonly used. The grounding electrode conductor connecting the ground plate to the service equipment must be sized according to NEC Table 250.66. Concrete encased electrodes, also known as UFA grounds, are grounding electrodes encased in concrete. These are commonly used in new construction and can provide a very effective grounding system. A concrete encased electrode must consist of at least 20 feet of bare copper conductor, not smaller than number 4, encased in at least 2 inches of concrete. The concrete must be in direct contact with the earth. The concrete encased electrode can be installed horizontally or vertically within the footing or foundation of a building or structure. The grounding electrode conductor connecting the concrete encased electrode to the service equipment must be sized according to NEC Table 250.66. Now let's discuss the importance of bonding in electrical systems. Bonding is the process of connecting 2 or more conductive objects together to establish a common electrical potential. This helps to minimize the risk of electric shock by ensuring that all bonded objects are at the same voltage. Bonding is required for various metal components within a building, including metal water piping, metal gas piping, metal conduit, and metal enclosures. The bonding conductors must be sized according to NEC Table 250.102, based on the size of the service entrance conductors. Proper bonding is essential for creating a safe and effective electrical system. Grounding, as we've discussed, is the process of connecting an electrical system to the earth to provide a path for fault currents. This helps to protect people and equipment from electrical shock and damage. Grounding is required for the service equipment, separately derived systems, and other electrical equipment. The grounding electrode conductor connects the service equipment to the grounding electrode, such as a water pipe, ground rod, or ground plate. The size of the grounding electrode conductor is determined by NEC Table 250.66. The NEC provides detailed requirements for grounding and bonding to ensure the safety and reliability of electrical systems. It's crucial to understand these requirements and follow them carefully when installing or modifying electrical systems. Consulting with a qualified electrician is always recommended to ensure that the work is done correctly and safely. Now let's consider some specific scenarios and how the NEC requirements apply. If you have a metal water pipe that is used as a grounding electrode, and you replace a section of the pipe with a non-metallic material, such as plastic, you need to ensure that the grounding path is maintained. One option is to install a bonding jumper around the non-metallic section of pipe. This jumper must be sized according to NEC Table 250.102 and must be securely connected to the metal pipe on both sides of the non-metallic section. Another option is to supplement the water pipe electrode with an additional grounding electrode, such as a ground rod or ground plate. This will provide a redundant grounding path and ensure that the electrical system remains properly grounded. If you have a detached building or structure that is supplied by a feeder from the main building, you need to determine whether a grounding electrode system is required at the detached building. If the detached building contains only a single branch circuit and does not contain any equipment grounding conductors, a grounding electrode system is not required. However, if the detached building contains more than one branch circuit or contains any equipment grounding conductors, a grounding electrode system is required. The grounding electrode system at the detached building must consist of one or more of the grounding electrodes recognized by the NEC, such as a water pipe, ground rod, or ground plate. The grounding electrode conductor must be sized according to NEC table 250.66 and must be connected to the grounding electrode and the equipment grounding bus in the panel board at the detached building. Separately derived systems, such as generators and transformers, also require grounding. The grounding requirements for separately derived systems are outlined in NEC section 250.30. A grounding electrode conductor must be run from the separately derived system to a grounding electrode, such as a water pipe, ground rod, or ground plate. The size of the grounding electrode conductor is determined by NEC table 250.66. An equipment grounding conductor must also be run from the separately derived system to the equipment grounding bus in the panel board. The equipment grounding conductor must be sized according to NEC table 250.122. In addition to the grounding electrode conductor and the equipment grounding conductor, a bonding jumper may also be required to connect the separately derived system to the building's grounding system. The bonding jumper must be sized according to NEC table 250.102. Understanding the NEC requirements for grounding and bonding is essential for ensuring the safety and reliability of electrical systems. By following these requirements and consulting with a qualified electrician, you can help to protect people and equipment from electrical shock and damage. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Furthermore, remember that electrical codes and regulations can vary depending on your location. It's crucial to check with your local electrical inspector or authority having jurisdiction to ensure that you're following the correct requirements for your area. The NEC is updated every 3 years, so it's important to stay current with the latest edition. The NEC is a comprehensive document that covers a wide range of electrical topics, including grounding and bonding. It's recommended to have a copy of the NEC available for reference when working on electrical systems. In conclusion, grounding and bonding are critical aspects of electrical safety. By understanding the NEC requirements and following them carefully, you can help to create a safe and reliable electrical system. Always consult with a qualified electrician and follow all applicable codes and regulations to ensure that the work is done correctly and safely. Remember, electricity can be dangerous, so it's always best to err on the side of caution. Investing in professional electrical services is a wise decision that can protect your property and the people who occupy it. Continuous learning and staying updated with the latest electrical codes and best practices are crucial for anyone involved in electrical work. This knowledge empowers you to make informed decisions and ensure the safety and efficiency of electrical systems.